Hi everyone, today we are going to talk about the projectile motion. So what is a projectile motion? It's a two-dimensional motion and it is only due to the gravity which cause the object to move along the y direction due to gravity. So which I will show you an example. What is a projectile motion? For example, I'm shooting this object and by the end it will fall on the ground. And the reason is due to gravity, it takes it down. So this is a simple example of 2D projectile motion. And so today the instruments we are going to use including a photo gate and time of flight pipe and the ball we are shooting with, which is a projectile. And the photo gate is for recording the initial velocity of the ball, which is coming out of the projectile, and the time of flight of pipe. This one will measure how long it takes for the projectile to come down to the ground. So this is measure the time, and this is a projectile we are using. And before we start, let's start with the physics behind these measurements. So projectile motion, now I draw a picture. For example, this is a ball we are shooting, and this is a motion along x direction, this is a motion along y direction. And suppose we are launching this projectile at 0 degree. So we are horizontally shooting an object. So the motion of this object, if I draw a line, it will something look like this. We just select line through this object and fall on the ground. So we could distinguish this motion as a motion along x direction and a motion along. Let's suppose when the ball leaves this projectile, the initial velocity is v naught. And suppose in this graph, the distance from the ball to the ground, this height, let's call this height is h, is a positive value. Okay? And so now we can distinguish x and y direction. So in the x direction, how the motion is, and in the y direction, how the motion is. So let's see for the x direction first. For the x direction, there is no actual force on this object because the object is moving along x direction only with a constant velocity, which is v naught. So we can write down along the x direction, the initial velocity is v naught. And with time change, this velocity doesn't change because there is no actual force. So there is no acceleration along this x direction. So this Vx is a constant equal to the initial velocity equal to v naught. And as time change, the distance changed along the x direction. Let's call when it falls on the ground, this position is x. The initial position is 0. So the distance change along the x direction, x minus 0, which equal to, because it's a constant velocity, so constant velocity times time. So this is the displacement along the x direction. Now let's see along the y direction. Along the y direction, initially we are only shooting the ball for initial velocity v naught along x direction. So initially in the y direction, the initial velocity v naught y is equal to 0. And with time change, how the velocity changes along y direction? Because along the y direction, there is an acceleration due to gravity. And this gravity is negative g. The negative sign means the moving direction is along the negative direction. Because we suppose the upward is positive, so the gravity is downward, so it's a negative value. So now with time change, this velocity Vy will equal to, if you remember, is equal to v naught y plus 1 over at, right? This is a time change with time change and acceleration, how the velocity will change. And in this case, v net y is E0, and here A is the gravity, which is negative g, so 1 over 2, so at. So just a gt. So along the y direction with time change, the velocity vy equal to negative g times t. And the displacement along the y direction. So initially, suppose the position is at y, the final position is at E0. When the force on the ground, the y value becomes E0. So del y will equal to E0, the final position, minus the initial position y, which is negative h, because h is the height for the position of the ball initially. So is negative h, which equal to v net y plus 1 over 2 at squared. Since the v net y t, since this v net y is 0, so and a is negative g, so this will give us negative 1 over 2 times g times t squared. So what is this equation tell us? By the end, we'll only get this relation, so which is telling us h equal to 1 over 2 gt squared. So if we just look at this equation, this can tell us how long it takes for the ball, if we're horizontally shooting a ball, how long it takes the ball to come to the ground. This t will equal to 2h divided by g under the root. So what is this telling us? For this projectile motion, when you are shooting an object horizontally without an initial velocity along this y direction, so the time of flight, how long it takes for the ball to come to the ground, only depends on the initial position of the ball, and the gravity constant is not related to the initial velocity at all. Okay? So it only depends on h and g. So this is an important conclusion we got from our first measurement. So we will do this measurement in our computer, So now there's another example. So first example was we are shooting the ball along the x direction. So in the y direction, there is no initial velocity. Now we are shooting the ball with certain angle above the x direction. Let's call this is the angle θ. So we are shooting the ball with angle θ above x direction. And also still we are measuring how long it takes for this ball to come back to the ground. So this time, we also distinguish the motion along x direction and also the motion along y direction. So along the x direction, the initial velocity will equal to, so this time, since v net has certain angle with the x direction, it's called this is a horizontal direction. Angle is θ. So the initial velocity along x direction will be v net times cosine θ. And with time change, the position change delta x will equal to x minus E0 equal to x equal to v net cosine θ times t. Along the y direction. Along the y direction, the initial velocity, let's call it v net y. This value will equal to the initial velocity times sine θ. And since there is a gravity along y direction, so this velocity is also changing with time along y direction. So Vy will equal to v net y minus gt, right? Because g is along the negative direction. So this will tell us v naught sin ct minus gt. And so the displacement along the y direction is suppose the height is the same, it's still h, right? So the displacement, the final position for y is at E0, initial is at y, so E0 minus y, since initial y is at h, so negative h, this is the displacement of the ball along the y direction, and initial velocity for the object, this time v naught y is no longer 0, so there is a value here, minus 1/2 gt squared. So this time from this equation, we can calculate what is the time takes for projectile when you shoot it with a certain angle. So we can write the final solution here. So equal to v naught sin c minus plus under the root v naught squared sin c squared plus 2hg, and then divide by g. So what this is telling us, so you can see for this one, the time of flight for this ball, when you are shooting the ball with certain angle along the x direction, it depends on the initial velocity you are using for shooting the ball, the angle you are using, and the height h and the gravity constant. So right now this time will depend on a few factors when you are shooting with angle. But when you are shooting with a horizontal direction, only 0 degree, it only depends on h and g. So from the experiment, we will see how these factors influence the measurement result.
Hello, this video is going to elaborate on this week's video for projectile motion. We're going to go through the calculation for a projectile launched at an angle for solving for t using one of our kinematic equations. So in the video, they had this equation and a few other equations which are helpful to solve for the velocity for y, displacement in x, the initial velocity for y, and the initial velocity for x. Now, these are great, but we need to know what t is. So we're going to solve for t using y equals minus h, which equals v naught sine theta times t, which is our v naught y, minus 1/2 gt squared. And minus g is the acceleration in the y direction, since the projectile is launched from up here and the negative y direction is straight down, which is what gravity acts in. So here we have an equation that depends on t squared. So we're going to rearrange this a little bit and say 0 equals minus 1/2 gt squared plus v naught sine theta plus h. So h was our y value, well, minus h, but we moved it to the other side. And we have minus 1/2 gt squared plus v naught sine theta times t plus h. So now that our equation looks like this, we can use the quadratic equation to solve it. And the quadratic equation just says that when we have an x value, like an x squared plus something times an x plus a constant, we can use this and say x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Now in our equation, our x is going to be t, b is going to be v naught sine theta because it's in front of the second term here, which is multiplied by the t, and the a is what's multiplied by the t squared, so that's minus 1/2 g, and the c is our constant value h. So if we plug all that in, we get t equals minus v naught sine theta plus or minus the square root of v naught squared sine theta squared. minus 4 times minus 1/2 g times h over 2 times minus 1/2 g. So if we simplify this, we get t equals minus v naught sine theta plus or minus the square root of v naught squared sine theta squared minus a minus 4 times a minus 1/2, so that would be plus 2 times g times h, all over 2 times minus 1/2 g, so that's just g, and then the minus will come up here and we'll just make this positive. So now we have an equation for t, and you'll notice that there's actually two solutions for t here, and the one that you're going to want to use is the non-negative one. So one of these solutions is going to come out negative, and obviously time can't be negative, at least not in this universe, so we choose the positive solution. And that is how you solve for t. And we can use this then to solve for vy, the velocity, when it hits the ground in the y direction, and then also for the range x. So there you have it.
Hi everyone, this is the setup for the projectile motion as you can see from the computer. And here, this is a photo gate. So this photo gate, when we put the ball, there are three ranges: short range, medium range, and a long range. So we will put the ball first at the short range, then we use the medium range. At different range, there will have different initial velocity. And when the ball shoots out, this is called the photo gate. This photo gate will record what is the initial velocity of the ball coming out of the projectile. And then once the ball comes out, it will fall on the ground. So when it falls on the ground, we will use this to hold on the ground. So the ball will fall on this one. This is called time of flight pad. So once the ball gets onto the pad, it will immediately record what is the time it takes for the ball from coming out of the projectile until it comes to the ground. So this is to taking the time. So for this measurement, as we discussed earlier in the blackboard, so when you shoot the ball horizontally, it's supposedly the time, how long it takes to come to the ground, only depends on the height of the ball and gravity constant. It doesn't matter you use short range or long range, whatever the different initial velocity, it will not influence the time. So from today's measurement, we will prove if that is true. So now let's start the measurement. So we will first start the short range with a plastic ball. So you can see this is, on this side it will record how long it takes. On this time it will record the initial velocity. So now we are using the short range. You can check what is, so we will do a few tests first to make sure the ball will fall on the pad first. Okay, so now we are starting our first measurement. So we place the ball at the short range already, and now we will shoot the ball and see what is the measurement value for the short range. Okay.
We didn't hit
I
record?
forgot to start, sorry.
It's okay.
Let's start over again. We need to start the recorder once we are ready for shooting this projectile.
Okay.
All right. Okay. So you can see from the computer, this is our initial velocity, and this is how long it takes. As you can see, the initial velocity from the short range is 3.15 meter per second, and the time it takes for the ball fall on the ground is 0.44 seconds. And now let's go to medium range and compare this value with the medium range value.
Huh?
Did it repeat on this?
We can do one more just to make sure it's consistent. Okay.
Okay, now let's start with the computer and record this data.
Okay.
Okay, so now this time you can see the speed of the ball is 4.9 meter per second. Earlier, if you remember, is 3.9. And now the time takes is 0.45 seconds. Earlier is 0.44 seconds. So it's very close. It's almost the same with each other. So this measurement tells us if we are shooting the ball horizontally, no matter what is the initial velocity, the time of flight for the ball is the same. So this is the conclusion for this measurement. Now let's go on for the next measurement. Let's shooting the ball with a certain angle. So this is the second part of this measurement. For this measurement, we want to compare when you are shooting this ball now with a certain angle, how the time of flight will change. Earlier, we showed if you change the initial velocity, the time doesn't change. But now, if we shoot with certain angle, first let's compare if we shoot this still with a 0 degree, compare with when we shoot at 35 degree. What will be the difference? Okay, let's now repeat the short range for the 0 degree of shooting this projectile.
Farther back a bit.
Okay, now let's start with the measurement. Okay, so this time the initial velocity is 3.14 meter per second, and the time is 0.46 seconds. So this is a horizontal shooting the projectile. Now let's shoot the ball with 35 degree. It's the same short range, which means we have the same initial velocity, but we are only changing the angle. Now the angle is 35 degrees. Okay, now we are ready for the angle shooting this projectile at short range. Now let's start. So now you can see a big difference. Now the initial velocity is still similar, around 3 meters per second, but the time now is 0.68 seconds. Earlier was 0.46 seconds, now it's 0.68 seconds. So there is a big difference. Now this is telling us when you are shooting the projectile with a certain angle, it depends on the initial velocity, depends on the angle, the position of the projectile, and the gravity constant. So it depends on a few factors. So we can do another measurement just to compare if at the medium range 35 degree, will this value also be different or it will be the same?
Back to 0? 0 degrees?
No, 35 degree medium.
Okay.
Okay, now we are good for the medium range with 35 degree, and let's start this measurement. Okay, so now again you can see the difference. This time, the time takes 0.84 seconds, and initial velocity is also different, 4.7, because now we are using a different range, but apparently this time is also different. So this telling us the conclusion is that with shooting with certain angle, it depends on the angle, the initial velocity, and the position of the ball, and the gravity constant. But compared to earlier, our measurement when you are shooting at 0 degree, only depends on the position of this projectile. So we can do a little simple calculation for this one. The angle we are using is 35 degree, and the launch height is about 1 meter. The initial velocity is the short range we recorded. I will give you the data on the paper. And then you can, based on this information, to calculate what is the initial velocity along x and y direction based on the equation they are given here. And then you can calculate how long it takes for the ball to get on the ground. This is from your calculation result. And then you can compare your calculation result with our measurement result, see if the time will be same or similar. And also you can do a calculation to calculate what is distance traveled along the horizontal direction, which is the r. Okay, so this is a measurement for the projectile motion.